Okay, so today we're going to talk about our first linear programming problem, and then really focusing on writing constraints and our objective function. A quick reminder that constraints are your inequalities that limit or restrict your solution region. So they restrict that. They are written as inequalities. Okay. Your objective function, that's an equation. This is the function that we are trying to maximize or minimize. And remember, it's often a profit or cost equation, but not always, okay? So keep that in mind. Okay, so let's look at this problem. Before we do that, I wanna just kind of point out some phrases that you're gonna see here. I'm gonna pause here and just give you a second to look at a few of these. Okay. The problem I chose here doesn't have any of those key phrases that we just looked at, kind of on purpose. I wanted to try one that's actually a little bit trickier here to start, so that you just have an idea of what these can look like and the variety that you'll see. Just like our English language can be so different when the way people write things, the same thing here. It's not always going to be set up exactly the same way. So now again, linear programming is used to find the optimal solution or the best solution. So if you are an effective business, you want to do this. So if you're a small business, the owner might do this. If you're a large business or corporation, you might have somebody on staff that's sole job is to just do this, or they have developed some type of software package to do this as well. Okay, so let's dive right in here. Yum's Bakery bakes 2 breads, A and B. One batch of A uses 5 pounds of oats and 3 pounds of flour. One batch of B uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour available. One batch of A yields a profit of $40. One batch of B yields a profit of $30. How many batches of each bread should the bakery make to maximize profits? Okay. So the first thing we want to really do here is define our variables. So I'm just going to say X. And if you're not sure what's going on, the easiest thing is to look at the last sentence. Okay, what is the question they're asking here? It says how many batches of each bread? Well, right there, that tells you what your variables are. It's batches of each type of bread. So I'm going to say X is bread A. And Y is bread B. Okay, now it doesn't actually matter for this particular type of problem which one you call X and which one you call Y. I always just say the first one is X and the second one is Y. So these are our 2 things though. And then the next thing, often people say, I want to write my constraints right away. I like to actually write my objective function first. Why? Because I don't want to get confused with all these numbers in here. I want to make sure I have everything laid out. And the objective function is a little easier to pull out. Remember, the objective function is an equation. It is the thing you are trying to maximize or minimize. Okay? So it says in the last sentence here, I'm going to change colors here so we are trying to maximize profits. So I know my objective function. I'm going to go down here. In my objective function, I'm going to use P for profit. And it's an equation, so I'm going to put an equal sign. Now you can use any letter there, but just it makes sense to use P for profit. So now I want to say, all right, I've got X and Y, which is bread A and bread B. Now, according to profits, what do we know? Bread A yields a profit of $40. Okay, so how do I write that? $40 for every batch of A, which is really X. Okay, and one batch of B yields a profit of $30. So plus 30Y. Okay, now that is my objective function. Notice it's an equation and I've got that. So I'll use that later, but now I know I'm not using any of these things right here in my constraints right here. Okay, so I don't want to get confused with that. Those are already done. So just kind of keep that in mind. So now really I'm just going to focus on this top part here, these things right here. Okay, so now that should consist of my constraints. All right. Now, when you start writing your constraints, you're always going to ask yourself, can you have negative of either of your two variables? So in other words, our variables are x and y, but they're bread A and bread B. Can I make negative batches of these? No. So I can't do that. So if that's the case, which almost always you can't have negative, but not always, because it is possible to go into the negatives. I can't make negative batches of bread A. So another way to write that as an inequality is x has to be greater than or equal to 0. 0 or higher. And the same thing with bread B. I can't make negative batches of those. So I'm going to say y has to be greater than or equal to 0 as well. Now, when you're doing linear programming problems, it may seem silly that you have to write this, but this is an important first step. Almost always you'll start by writing, hey, I can't have negatives of either of those. And that's the case a lot of times with these linear type of programming problems and the real world situations. Now you'll notice the graph also is only quadrant 1 where it's only positive net values, so that's kind of already has those things built in. Now let's get up into our problem here and take a little bit more of a closer look. So we have two breads, A and B. One batch of A uses 5 pounds of oats and 3 pounds of flour. One batch of B uses 2 pounds of oats and 3 pounds of flour. The company has 180 pounds of oats and 135 pounds of flour available. So in this one, they're trying to trick you. They're trying to mix things up so that you get confused. Really what we want to do is write a constraint. Our constraints are we only have so much pounds of oats and so many pounds of flour. So what I really want to look at is what is a constraint on oats and what is a constraint on flour. So here, let's look at our oats. Every batch I make of batch A uses 5 pounds of oats. Okay? And every batch of B uses 2 pounds of oats. So hopefully that makes sense that that's 5x, or 5 times however many batches of bread A, plus 2 times however many batches of bread B. And now I only have how many pounds of oats? 180 pounds of oats available. So that means I can go up to 180, but I can't go over. So that has to be less than or equal to 180. Okay, now next I want to identify flour. Okay, it says batch A, 3 pounds of flour. Batch B also uses 3 pounds of flour. Okay, and they have 135 pounds of flour available, so less than or equal to 135. Now, this one tries to confuse you by mixing things up like that, and that's why I wanted to go over one of those. They also don't, you'll notice here, none of these phrases that you'll see on this right here are in this problem. So this is one you have to be a little bit more sneaky about how you come out with these constraints. Okay, so these are my constraints, and this is my objective function right here. Okay, so those are the things that I need to make sure I have before I can graph and go any further. Hopefully that makes sense. You'll get some more practice with this on your assignment.